everyone. Today we are looking at chemical monitoring and management, and in this topic we will look at the Le Chatelier's principle. Le Chatelier was a scientist who looked at equilibrium reactions and determined what factors disturb the state of equilibrium. So what conditions favors the forward reaction and also what conditions favors the backward reaction. Let's look at what's the most important thing when we perform a chemical process. So for any chemical process, the correct raw materials need to be brought together in the right place, at the right time, under the right conditions. And chemists needs to carefully monitor processes to ensure optimum conditions. And why is that the case? We already saw that in a combustion reaction, the amount of oxygen determines the amount of carbon dioxide formed. So if we reduce the amount of oxygen, the amount of carbon dioxide, which is the product we want, will also be reduced because some of it will be converted to carbon monoxide and carbon soot, and we don't want that. Hence, it's very important to ensure that the optimum conditions for a reaction is met. So what conditions do we need to look at? We need to look at the concentration of reactants and products, the presence of a catalyst, the temperature, and the pressure only if gases are involved. Now, why is that? Because the concentration of reactants and products, the temperature, and the pressure will disturb the state of equilibrium. So if we change any one of these, the forward reaction or the backward reaction would be favored. So we need to ensure that these are at the right amount. And also, why is the presence of catalyst is important? Because the catalyst will determine whether the reaction is proceeding at a considerable useful rate. So we need to ensure that the reaction is not too slow, because then if it's too slow, it will be more costly. Hence, the presence of catalyst needs also to be monitored. Now, what does the Le Chatelier's principle state? Le Chatelier principle states if a system is in equilibrium and a change is made that upsets the equilibrium, then the system alters in such a way to counteract the change and a new equilibrium is established. Now, what does this mean? So if you have an equilibrium reaction and a state of the equilibrium is changed, for example, if you change the concentration of the reactant, then the equation will move forward to reduce the amount of extra reactants. So the forward reaction and the backward reaction occurs at the same rate. So the amount of products and the amount of reactants are equal. So if you alter any of the factors of equilibrium reaction, such as temperature, concentration, or pressure, then the reaction will move forward or backward to counteract that change. Now let's look at the rules of Le Chatelier's principle. So if the forward reaction is endothermic, what does endothermic mean? That the reaction is using energy, such as heat energy, to form the products. So energy is one of the reactants. So if we increase the temperature, then the formation of product will be favored, because increasing the temperature in an endothermic reaction means adding more reactant, and the equilibrium will move to the side to reduce the extra added reactant. Hence, the formation of the product will be favored. As a result, in an endothermic reaction, if you increase the temperature, the yield of product will also increase. Now, what happens if the reaction is exothermic? What does exothermic mean? Exothermic means that heat energy is one of the products of the reactant. So this time it's not a reactant, energy is a product. So if you reduce the temperature, so you are reducing the amount of heat involved in the reaction, again the formation of the product will be favored. And why is that? Because as we can see in an exothermic reaction, heat is one of the products. So if you reduce the heat, then the reaction will move forward to produce more heat. Again, the yield of the product will be increased. And these rules apply to all sorts of reactions. So it doesn't matter whether your reaction involves solids, liquids, or gases. The rule for temperature applies to all types of reaction. Now let's look at pressure. Now the rule for pressure only applies to reactions that involves gases. So the reactants are gases, as well as the products formed will be gases as well. So it only applies to reactions with one or more gases, reactants or products. So it doesn't matter if you have 2 molecules of gases or 3 molecules of gases or 1 molecule of gases. Whenever gases are involved, you need to consider pressure. You need to monitor pressure. Now, why is that? If you increase the pressure of a system by reducing the volume, the equilibrium will shift to the side with the least number of gaseous molecules. And why is that? Because if you increase the pressure, the equilibrium will move to the side that will reduce the pressure. And to reduce the pressure, it needs to move to the side where there is less number of molecules involved. Hence, it will move to the side with least number of gaseous molecules. What happens if we decrease the pressure of the system? So if we decrease the pressure of the system by increasing the volume, this time the equilibrium will move to the side with more number of gaseous molecules. So if you have more number of gaseous molecules, the pressure will be increased gradually, and that's what the equilibrium will do. If we decrease the pressure, it will want to do something that increases the pressure and brings it back to normal. Hence, it will move to the side with the most number of gaseous molecules. And if there are equal number of molecules on both sides, so the reactants have equal number of gaseous molecules and the products will also have equal number of gaseous molecules. And thereby, if you change the pressure or volume of the reaction, it will have no effect, because on both sides there are same number of molecules. So the equilibrium cannot move to either of the sides to either increase or decrease the pressure. Hence, if the reaction involves equal number of molecules, then changing the pressure by increasing or decreasing the volume will have no effect on equilibrium. Now let's look at how concentration disturbs the equilibrium position. So if we increase the reactants concentration, so we increase how much reactants are involved, the equilibrium will shift to the right to make more product. And why is that? This is to reduce the concentration of added reactant. So in a reaction, if you add extra reactions, then extra reactants, then the amount of extra reactant added will be converted to products to reduce the extra amount of reactant added. So that's what equilibrium will do. It will try to stabilize the reaction, and hence it will move to the right. And what happens if we decrease the amount of reactants? If we decrease the amount of reactants, the equilibrium will move to the left. Hence, more of that reactant is formed. For example, if you reduce one of the reactants in the reaction, the product will actually dissociate to form more of the reactants, because the amount of reactants is low. So the equilibrium will try to increase the amount of reactant to stabilize the reaction. So both the forward reaction and the backward reaction occurs at the same rate. And to do this, it will dissociate the products to form more reactants, and as a result, it will decrease the concentration of the products. Now let's look at catalysts. What does catalysts do in equilibrium reaction? Catalysts make the reaction go faster. They do not affect the position of equilibrium, because catalysts cause the forward and the reverse reaction to speed up by equal amount. So it ensures both the forward reaction and the backward reaction are proceeding faster but at equal rate. So both of the reactants proceed at equal rate but just faster. So the catalyst does not alter the temperature, concentration or pressure, any of the factors that will hamper with the amount of reactants or products. Therefore, it does not affect equilibrium. And why are catalysts useful? Because it lowers the activation energy. How does catalyst lowers activation energy? It lowers activation energy because it increases the amount of energy needed to, it provides extra energy to break the bonds of the reactant so that they can join together to form the products. So the amount of energy that is needed to break the bonds will be lowered, hence the activation energy will be lowered. And this ensures that the equilibrium is achieved faster so that we don't have to wait long periods of time for the reaction to reach equilibrium. And this will reduce the amount of costs involved in the reaction. And this is definitely important in industry, as there are considerable savings to be made, such as time. If equilibrium is reached faster, then less time is needed for the production of the products, and also energy, because if you use catalyst, the activation energy is lowered and hence energy will be saved, which will result in a lot of cost being saved. Now let's move on to questions to test your knowledge. Question 10. Question 10 asks us, an understanding of Le Chatelier's principle is important in the chemical industry. Which prediction can be made using this principle? So the identity of the product of a chemical reaction. Now Le Chatelier's principle does not involve the identity of products or reactants. It only looks at the rate of reaction and what favors the forward or backward reaction. Hence, it's not the answer because Le Chatelier's principle describes what happens if equilibrium is disrupted in a reaction and not the identity of product or reactant. So A is not the answer. What about B? The effect of changes in temperature on the rates of reaction. Again, temperature, the effect of change of reaction will hamper the equilibrium position, so whether the forward or backward is favored, but then again have no effect on the rate of reaction. So B is not the answer again. What about C? The effect of catalyst on the position of equilibrium reaction. As we already know, catalyst does not affect the position of the reaction. It only affects the rate of the reaction, so it ensures that both the forward reaction and the backward reaction proceeds at the same rate but just faster. So C is not an answer again. What about D? D tells us the effect of changes in the concentration of chemical substances in an equilibrium. And this is true. Why? Because if we change the concentration of either the reactant or the product, the equilibrium will move to the side to counteract the change. So if the amount of reactants are increased, it will move to the side will reduce the amount of reactants by forming the products. Again, if the amount of products are increased, it will move backward to reduce the amount of increased product and form more reactants. Now let's look at question 11. Question 11 tells us, explain why the synthesis of ammonia has a high activation energy. So to form ammonia, we know that nitrogen and hydrogen atoms must combine. So the nitrogen and hydrogen atoms must break to form ammonia because they need to combine. Now, nitrogen and hydrogen atoms do not exist as single atom. So for nitrogen, we know it's N2, for hydrogen as well, H2 molecules. So they both exist as diatomic molecules. Diatomic means that two molecules of nitrogen will exist in air. So you will never have a nitrogen atom like this existing in air. It will always be in the form of a molecule. And same with hydrogen. Hydrogen will always occur as H2, never as H. So as you can see, they are already stabilized. So N2 is a stable molecule and H2 is a stable molecule. And you need to break the bonds between these molecules so that they can join together. Now, so both of these exist as diatomic molecules held together by covalent bonds. So the molecules between them are covalent. Now, nitrogen molecules are held together by very strong triple covalent bonds. So between the nitrogen molecules, there are actually 3 covalent bonds, and the single covalent bond between hydrogen atoms is also quite strong. Therefore, a lot of energy is needed to break these bonds and form the atoms that can rearrange to form ammonia. Hence, that's why we need a lot of energy. A high activation energy is required to synthesize ammonia to break the covalent bonds. And this is called the activation energy, the energy needed to start a chemical reaction. And therefore, the activation energy is high because it needs to break the covalent bonds between nitrogen and hydrogen so that they can combine together to form the product ammonia. Now let's look at question 12. Question 12 tells us to highlight the correct words. So let's look at A. Overall energy is released or absorbed in the reaction of hydrogen with nitrogen to form ammonia. So we know that the reaction of ammonia is an exothermic process. Hence our answer will be released, because in exothermic process we release the amount of we release energy. Hence the overall energy is released in the reaction of hydrogen with nitrogen to form ammonia. And there is more or less chemical energy in the product than in the reactants. So again, it's an exothermic reaction, and what does that mean? It means that less chemical energy in there is less chemical energy in the product than in the reactants, because it's an exothermic reaction. So the amount of energy is released. What does B tell us? The energy needed to break the bonds in hydrogen and nitrogen is more or less than the energy given out when the new bonds in ammonia are formed. Again, you need to look at the fact that it's an exothermic reaction, and which means less. The bonds in hydrogen and nitrogen is has less amount of energy that's given out when the new bonds in ammonia are formed. Again, because it's an exothermic reaction. And what does C tells us? The bond in ammonia are stronger or weaker than the bonds in reactants. And we already know that the bonds in ammonia are weaker than the bonds in reactants, because as you should remember, the nitrogen has triple covalent bonds, whereas ammonia only has single covalent bonds between the nitrogen and the hydrogen molecules. Now let's move on to question 13. Question 13 asks us to state Chatellier's principle, and that is, if a system is in equilibrium is changed, the system will adjust to minimize the change. So for example, if you change the concentration of reactants, if you increase the concentration of reactants, the formation of products will be favored, so that the extra reactant that is added is reduced. Hence, if a system is in equilibrium is changed, the system will adjust to minimize the change. Now let's move on to question 14. Consider the following reaction at equilibrium. So let's look at the reaction. So nitrogen reacts with 3 molecules of hydrogen to form 2 molecules of ammonia. So they asked us, what would be the effect of a decrease in pressure on the system? So they will decrease the pressure. So the equilibrium will not be disturbed. Now this is false, because the reaction involves gases. So you can see all of these reactants or products are in the state of gases. Hence, equilibrium will be disturbed if the pressure is changed. Hence, this is not the right answer, because it suggests that equilibrium will not be disturbed. Let's look at question part C. C tells us the concentration of ammonia will increase. Now, in this reaction, if we decrease the pressure, the reaction will move to the side that will increase the pressure. And to increase the pressure, we need more molecules. And as you can see, the number of molecules on the product side is 2, and the number of molecules on the reactant side is 4, because there is 1 molecule of nitrogen and 3 molecules of hydrogen. So the total number of molecules on the reactant side is 4, and on the product side is 2. Hence, the concentration of ammonia will not increase, because the reaction will move backward to increase the number of molecules, and for the reaction to move backward, the ammonia will dissociate, which means the amount of ammonia will decrease. And let's look at D. D says the reverse rate of reaction will decrease. Now, the change in pressure will not increase or decrease the rate of reaction. It will only affect which side of the reaction is favored. Is the forward reaction favored or the backward reaction favored? But in this case, again, the reverse reaction will be favored, because we know the reaction will proceed to the side that has more number of molecules. Hence, our answer is A. And why is that? Because it suggests heat will be absorbed. And we know that the reaction is exothermic. From what? From this negative sign. This means that energy is released. So energy is one of the products. Therefore, if we decrease the pressure, the reaction will move backward to increase the pressure to form more molecules. As a result, heat will be absorbed, because the backward reaction is endothermic. This brings us to the end of the question session. In this topic, we looked at Le Chatelier's principle and the different things such as temperature, pressure, catalyst, and concentration of reactants and products affect the state of equilibrium.